Okay, we're going to go ahead and get started. My name is Rod Alberts. I'm the Executive Director of the Detroit Auto Dealers Association and also the Director of Motorbella. So it's a pleasure to be here, and this is the one symposium I'm introducing primarily because John Waraniak is a dear friend of mine. We've worked together for years, and I've done some programming with him at SEMA and a few other locations. But he is one knowledgeable guy when it comes to this industry and auto racing and everything else, and technology and to boot. So, John, thank you for allowing me to be a part of this and say a few words. I do want to talk about Motorbella a little bit in regard to what it all means. You know, what I saw happening here in regard to what we were doing at DAD, I've been with the auto show for 30 years. I've worked at Atacobo Center during that time, downtown, indoors with a static auto show. We came to realize that things weren't changing incrementally anymore. They were changing very rapidly in technology, as obviously everybody knows. And we made the decision during this pandemic, when it even accelerated change even more, to take the show and put it into an engaging and experiential environment that we could do things and put people in cars, put the media in cars, and do it different than anyone else. We made this decision about 6 or 8 months ago, and I've been working with Tim McGrain. Tim's here right now, and we appreciate everything Tim does. He runs it out here, came out of Laguna, and a big history of auto racing and locations like this around the world, Goodwood, you name it. He's done it all. But it took a partnership like this to bring it out here and make something happen different than anybody else has ever done. Having a location like this in the metro heart of a city like we have, or the region, very rare to have those kind of tracks and places to go with 87 acres to work with. This was a vision we had. It came together incredibly well, and I think a lot of people are shocked at what can be done in different situations during a challenging and crisis that we've been in. But there's one thing that I know and I've learned for sure. You cannot sit on the sidelines and wait for things to just work around you. I came to realize when everybody else is just doing the same old thing, let's do something a little different and make a difference. And there's a payoff to this. We all learn from it. We find things can happen. Weather is part of the mobility world too, so we just kind of embrace that. But the beauty is we're doing it different, and we made it through when a lot of shows didn't make it this year in a safe environment. So again, being a part of this, having you here, having the symposiums that we're doing today, and having John Waraniak, who more than a friend but a leader in this industry, is one of my best friends and a true heart and soul in this, what we're doing, is really a pleasure and an honor on my part. Again, this program we're going to have, and I'm going to turn it over to him, it's called Going to Gemba, Faster, Smaller, Cooler, and Safer, and it has to do with racing and what it means in technology and how it all is coming together and how it's showing the future and what it means for even safer cars and what we're doing in our environment, et cetera. So at this point, I want to bring up John, my friend, and I want to thank everybody again for being here today. Thank you.
Well, thank you, Rod. That was excellent. And again, I think we're here today. We're making history, a lot of us, what Rod just talked about with Motorbella. And that truly is going to the Gemba. The Gemba, it means the front line. It's a Japanese term for going to the place of action. And we're going to talk about that. And I also want to thank Tim McGrain here, CEO and President of M1 Concourse. This couldn't have happened without a lot of people, but the leadership and vision of Rod and people like Tim that made it happen. So thank you, Tim, for putting this together. It cannot have been easy. Just a year ago on the job, and here we are with kind of the interim auto show, if you will, for Detroit. So cool stuff. So welcome. Good afternoon, and welcome to our session, Going to the Gemba, Faster, Smarter, Cooler, and Safer. And we're going to talk about that. And thank you all for being with us here today. I'm John Waraniak, and I'm going to be your moderator today. But I want to talk today a lot with these great folks we have up here today about motorsports and racing and how it's always been the Gemba. It's always been that front line for actually accelerating innovation and product development and engineering. It has been since the beginning of racing, since 2 cars were created. Racing is part of our connected, autonomous, and electric future. There's no doubt about it. And if you look at a lot of these great displays around here in Motorbella today, you can actually see that in making our cars faster, smarter, cooler, and certainly safer. Racing is centered on 3 key principles. Problem solving, number 1. 2, demonstrating technology and doing those 2 on the world stage. Solving problems and demonstrating technology on the world stage. 3rd, inspiring the next generation of engineers, STEM and STEAM leaders, and industry leaders. And that's all happening through racing, and it's happening very much in a faster pace today with some of the things we'll be talking about. There's a fundamental connection between the racing developed on the racetrack and what you eventually see in your car, in your driveway, or on the road. We're going to talk about some of that as well. And you heard about that from some of the other sessions, from ADAS, Advanced Driver Assist Systems. We're going to talk about true level 4 and 5, SAE level 4 and 5 autonomy today as well. So we're going to talk about a lot of that today, and we got some rock stars to do that. But to kind of level set that, I want to introduce you to something that some of you may be aware of right here. We're going to show a video that's coming up here in just a second. But on the 23rd of October, history will pass into the impossible with the Indy Autonomous Challenge. And you see the car right here. This was the first Dallara. They're all Dallara chassis, by the way. This is the AV21 that will be racing. This is the prototype, and there'll be 10 vehicles racing for $1 million prize at the Indianapolis Motor Speedway on the 23rd of October. So some university is going to take away that $1 million prize, and we're going to talk about that. But let me level set you right here with a video. Doug Boles couldn't be with us here today, but this will give you, this video, if we could play this video, will give you a good backdrop of how Indy has played a role in the racing capital of all of us, as well as the Indy Autonomous Challenge.
For more than a century, the Indianapolis Motor Speedway has pushed the limits of innovation, safety, and speed. Founded by Indianapolis businessman Carl Fisher, IMS was designed as a proving ground for America's emerging automotive industry.
Welcome race fans from Indiana, the United States, and around the world.
Today, as 300,000 plus fans gather at IMS each year for the greatest spectacle in racing, the spirit of innovation endures. And tomorrow, a new chapter begins. Introducing the Indy Autonomous Challenge, $1 million high-speed autonomous vehicle race featuring the next generation of automotive, robotics, and AI innovators from around the world. Teams from top universities are signing up to join premier organizations, including Energy Systems Network, Dallara, and Clemson University's International Center for Automotive Research in this effort to advance mobility technologies that can help save lives on vehicles today while growing the automotive industry of tomorrow. The Indy Autonomous Challenge is a 2-year journey comprising 5 rounds of simulated and on-track development and competition, and culminating with the final race on October 23rd, 2021, when autonomous Dallara race cars will compete side by side at up to 200 miles per hour to win the $1 million top prize.
So that's kind of a quick snapshot of what's going to happen with the Indy Autonomous Challenge. And basically right now we have 21 universities from 9 countries around the world that are racing, going to compete with 10 cars at the Brickyard on October 23rd. They've all practiced. Many of the students from all those universities have been staying down in Indianapolis, some since Memorial Day, back at the 500. So they're doing a lot of the testing. We're going to hear about that from Chris Paredis from Clemson. A lot of the cars have qualified. And I really want to stress this point, and please take this note away. This is not about taking the driver and the race driver out of the loop. There'll always be a Scott Dixon, a Takuma Sato winning the Indy 500 in our lifetimes. This is about solving extreme autonomous vehicle edge cases. How many folks watched the Laguna race or were at Laguna this past Sunday? Colton Herta, right out there, right from the pole position, leading race. What happened? About 10 laps from the end, a rabbit runs across the road, the track, and he hits the front wing, left side of the front wing. Could have been disastrous. There is no way you're going to program that into an edge case on an autonomous car. It'll take something like 800 billion miles, which is about 500 years of testing for GM, Ford, or Audi, or Tesla, to do that much testing. So you're going to have algorithms that can handle those extreme edge cases. And as my good friend Wilfred Eibach says, it's your popometer. That's how Scott Dixon drives fast. That's how Takuma wins races. That's how Colton Herta won on Sunday. You have to get that type of what's in their head into an algorithm and get them to make the car safer. So solving the extreme edge cases is what we're going to talk about. I want to kind of talk about a little bit what Doug would have talked about, that the Motor Speedway has always been the catalyst for a lot of this stuff. I don't know if Herb Fischel's here. He was one of my mentors at GM Racing. Herb and I, we started a program, not back in '64. This was the first beginning of autonomy, if you will. But the point I wanted to make here was hot rodders and today's digital hot rodders, but the hot rodders of the 50s and 60s defined an era, and more importantly, an attitude. And you see that out here with the next generation of enthusiasts, motorheads, as well as chip heads, and certainly the gasoline people. You're seeing that combination come together. It's that attitude that's going to prevail, and we're going to see that next generation, as well as attitude, define electrification, autonomy, and a lot of stuff we see. That's me as a young engineer in 1997. We flash forward from 64 to 97. We did the first autonomous vehicle test track on the La Jolla Freeway outside of San Diego for 15 miles. We buried sensors in there with these companies, Hughes Aircraft, Bechtel, GM Racing led it. It was really cool. But again, it was 8 Buicks, and Johnny McElroy remembers this. Their hands were up, and it was the first time we actually demonstrated that. That was way ahead of its time. That's not what we're talking about today. Today is different. We're talking about autonomous vehicles and the technology that'll drive a lot of that safety we're talking about. The other big thing that came out of racing was the first event data recorders. There were no crash data recorders on vehicles prior to 1990. It did not exist. When Tommy Kendall crashed at the Glen, Rick Mears crashed in his IndyCar, there was no data reconstruction. They went from basically 9 Gs to 0 Gs and 30 to 60 feet, depending on the accident or the shunt. That's a tremendous amount of G-forces on the body, the heart, etc. Well, now we have the event data recorders. IndyCar mandated them 1993, NASCAR a little bit later, 2002, but now we can reconstruct those. And if you look at Ryan Newman's crash from the 500 a couple years ago, just think of Roman Grosjean, his fiery crash in F1 last fall, on the Halo with the Red Bull car with Lewis Hamilton a couple weeks ago. And you can't forget Tiger Woods' crash back in February. Very first thing the LA County Sheriffs asked for was the event data recorder to vindicate and actually show that Tiger, in this case, was doing the right thing. He was a little over the speed limit, but again, he was in full control of the car. So very much a big part of our lives now, and that's on every one of your cars that you drove here to today. This is our speaker grid today, and I am honored to be up here with these rock stars. We're going to get into some of this with Beth Peretta, first woman team to qualify the Indy 500, just this past May, right? That's history in the making. She'll talk about how they created history. And if you think you're nervous, think about being on the bubble like Beth was with her team back on Memorial Day. And Chris Paredis, he's the head professor of automotive engineering at Clemson, basically the head of this program with all the great STEM and STEAM students who have been involved. And good friend, Dr. David Gorsich, head of the Ground Vehicle Systems Command, the chief scientist. So what the heck is military doing here? Well, a lot of the technology from the private enterprise ends up being transferred to the military, and it goes both ways. You see the GM Defense, the JLTV, Colorado derivative, if you will. Off-road racing, we'll talk about that as well, is huge. It's probably one of the biggest market trends today, particularly overlanding and off-road, like the king of the hammers. Taking EVs and creating a new, what I'll call a land missile. The new trophy truck will be EV racing at King of the Hammers, starting this year, as well as Baja and the Mint 400. So a lot of great folks involved with that. So with that, well, I'm going to actually go back to that. I'm going to leave that slide up. Can we leave that slide up? Put that slide back up, please. What I want to do is each of the speakers here, they're going to take a few minutes to introduce themselves and any key messages that they want to make sure you're aware of that we want to talk about. And then we're going to have a discussion, very interactive discussion among the panelists, among themselves about some of the key questions. We'll talk about what's the talent pipeline look like, what's the transfer of technology that's taking place from Indy Autonomous Challenge to Indy cars, what do the drivers think of this, that type of thing. And we're also going to talk about a lot of the different things that each of these speakers. So Beth's going to kick that off from a traditional motorsports connection and from the next generation for STEAM and STEM students, particularly women. Chris Paredis is going to talk about what's happening at Clemson and the talent pipeline. Dave's going to talk about the transfer of the technology, what he's learning with a great program you'll hear more about called Viper, which is the digital twin and the generative design that's taking place to eliminate a lot of the tooling and prototypes to get there faster, to save our lives and a lot of our heroes' lives, if you will, that are fighting for our freedom. So with that, I want to introduce Beth Peretta. Beth?
Thank you, John. Thanks for inviting me, and thank you to M1 for hosting Motorbella. This is fantastic. So the big question is why? Why a women's team in racing? Why does it matter? I know there's a lot of chatter about getting women in STEM, and this might seem very obvious right now, but I started with this idea at the end of 2014, and although that was not that long ago, it was 7 years ago, it wasn't talked about. So now it seems like it's a bit of the zeitgeist, but it wasn't at the time, and I told a few people about the idea, and sometimes I was met with blank stares, and sometimes, more often than not, people got it instantly of why it mattered. My background is in automotive and performance vehicles and racing. I actually worked for Fiat Chrysler and ran the SRT, the marketing and operations for the SRT brand and all of racing. And in that role, and some previous roles within automotive, I saw that although racing very much is technology. We look at the Indianapolis Motor Speedway, which has, been the Indy 500 started in 1911, and we look at all the things that we can trace back to being invented on the racetrack. We know that it's an incubator. It's a living lab. Car companies have raced for two reasons. One, advertising. We want you to see that our car won on Sunday, and you in theory, are going to buy on Monday. But realistically, it's where engineers can get quick answers, solve problems, and all that entails. But car companies also can recruit the best and brightest. They use it as a tool to either take engineers that already work for their companies, cycle them through racing, and have them learn in a very quick way. They can, as I like to say, racing is not for the mediocre. It will spit you out. So you have to be good at what you do. And racing is a good way, it's a good measuring stick. So why a women's team? What does that matter? Yes, there's engineering. We want to get kids involved. We want to get women involved in engineering. But realistically, at the heart of all this is commercial reasons. I want people to watch racing. Racing is still a commercial enterprise. It's a sport. And we need people to watch it. And if they watch it, maybe what Chevrolet's doing will lead to buying cars. Or maybe having Rocket Mortgage on the side might make you Google Rocket Mortgage, which was one of my sponsors, and find out what they do, and I need to buy a house. Oh, here's a mortgage company. Or I'm going to figure out, what PNC Bank does. Any of those sponsors. It's a big commercial enterprise. Yes, it's sport. It's all of those things. And why we're talking about autonomous vehicles and all that stuff, yes, that's a huge element. But fundamentally, it's still a commercial enterprise. So why do I want to get women involved? Because I'm going to increase an audience. If I can increase an audience, it's a whole life cycle. If I can increase an audience, we have money for things like that. Things like that go to the road cars. So if it's a life cycle, all of those ingredients matter. And if everybody kind of contributes and pulls the rope in the same direction, we'll have progress. So yes, we're not going to take the drivers out of the cars. Things like this are fascinating. We'll get into it. I like the idea of there's so many, if you look through the history of racing, the amount of safety that has come from race cars that go into road cars, but racing is still highly dangerous. And I'm excited to talk about where the future goes and what we can do to kind of push the limits. So my team qualified for the Indy 500 this year. It might look like an overnight success. You might not know my name. People in racing know who I am. But our team was 70% women. It wasn't ever meant to be 100% women. But the idea is that, so a team of 30 people, 20 of my team were women. And we almost didn't make it on qualifying day because of a mechanical issue, actually, a bit of equipment failure. But everybody says, well, why did you start with the Indy 500 if you're starting a race team? It was a long time in the making. I partnered with Roger Penske, who about a year and a half ago now, bought the Indianapolis Motor Speedway and the IndyCar Series, and also launched a diversity initiative. I've known and worked with Roger for years. I used to manage the motorsport programs when I was at FCA. We won a NASCAR championship together, his first NASCAR championship, Dodge's first championship since 1975. Knew him previous to that as well, and I partnered with him, and he's never had a partner team before, so that was also certainly a feather in our cap. And I like to say that my target audience is 10-year-old girls, 10 to 12 years old, for them to see what's possible. And yes, STEM education, interesting. We want to get more talent into STEM, regardless of gender, regardless of race, all of those things. But why specifically I focused on women is education leads to careers. Careers for women leads to financial independence. That gives women the agency to be self-sustaining, self-supporting, and it leads to a safer life for them and a safer society. So it seems like a lofty goal, but I'm talking to the fans in the stands, the fans at home. And I have to tell you, the most exciting thing were the letters, emails, tweets, everything that I got from fathers of daughters that said, I'm excited because for the first time ever, my daughter sat and watched the race with me. So I know we're making progress in little ways. And is that little girl going to grow up to be a racing driver or racing mechanic? No, but she might now know that anything's possible. And that's what my team's about. Thanks.
Good afternoon. My name is Chris Paredis. I'm a professor at Clemson University in the Department of Automotive Engineering. And my focus at Clemson University is actually on systems engineering, systems integration. And an important part of that is my educational role in which our master students, over the 2 years that they are at Clemson University, can participate in a Deep Orange project. Deep Orange basically is the program that produced a vehicle like this. This was built by our students, developed, engineered, and ultimately developed the prototype of this vehicle during the 2 years of their master studies. It's an opportunity for these students during those 2 years to experience the entire product development life cycle of a vehicle. They get an opportunity not only to dig very deep into a particular subsystem that they have a particular interest in, but they get to experience that in the context of a full vehicle development program, interacting with their peers who are interested in the other subsystems, making sure that all of the individual subsystems come together and ultimately lead to a successful vehicle. We create one of these vehicles, one new one every year. We start a new one and we finish a new one every year, but each vehicle will be developed over the course of 2 years. And of course, this one here is Deep Orange 12th. This is the 12th vehicle that we're doing. We're currently already halfway through the Deep Orange 13 project. But it's a great opportunity for our students to learn how to become better automotive engineers. We'll talk more about what we call Deep Orange 12, or what John called AV21, the vehicle that is going to be used for the Indy Autonomous Challenge. And that our students basically, over the course of those 2 years that they were in the program, designed and engineered. It's been a true challenge. And what I would like you to take away from this is basically that it's these types of vehicles that get our students excited. This is truly what our students get up for in the morning and work until late at night, making sure that these vehicles come together. This is the motivating factor for them to go through this learning experience. And I think it's a learning experience that is difficult for them to obtain in any other way than being part of a full project, a full development of a vehicle, more so than digging deep into one aspect of a vehicle once they go into an automotive job. So we'll speak more about the vehicle. I'm turning it over to David.
Thanks, Chris. Thanks, John, for inviting me. I am David Gorsuch. I'm the Chief Scientist for Ground Systems for the U.S. Army. You know, I'm really happy to be here, and in particular, why is the Ground Vehicle Systems Center, which I belong to, here? If you look back in history, from World War II, when President Roosevelt saw what was happening when war broke out in Europe with Germany, we looked and said, you know, we need to really leverage our auto industry. We need to build a Detroit arsenal. And so that was really formed back in the days of World War II. And also the Tank Automotive R&D Center, now called the Ground Vehicle Systems Center, was formed. And we really focused on how can we leverage what's happening in the auto industry to help develop systems that are going to do mechanized warfare like you see today. And so we really draw from the auto industry and from academia to say, okay, what technologies are there? And then what unique requirements do we have? For example, going off-road at high speed, you know, dealing with not just crash, but blasts and ballistics on our vehicles. So we have unique requirements, and we have in our own R&D program to basically leverage what the auto industry does in academia, but also take care of the special requirements that we have from a military perspective. So I'm really happy to be here, and really drawing off the automotive racing industry. You know, they look at high performance systems, and that's what we do too. We want to have high energy density engines. We need to have vehicles that can withstand blasts. And what's the analogy from the auto industry? The auto industry analogy is essentially crash. And in fact, when we ran into IEDs in Iraq and Afghanistan on roads, we had these underbody blasts killing many, many soldiers. Is blowing up their tibia and fibias and legs and spines, and we had to do something. And so we were called in the action to say, okay, how are we going to really redesign our vehicles? And one thing we did do was draw from the auto industry and people from the crash business. At that time, the auto industry was going through a downturn, and we picked up a lot of engineers and scientists that knew the crash business. So you said, instead of the vehicle going front end, hitting another vehicle or hitting a vehicle from the side, we're worried about a blast going up underneath a vehicle. And so guess what? There are different challenges. For example, the shock wave is a lot faster. It's a much higher order of magnitude, and the direction is different. And vehicles aren't designed to handle a crash from underneath the vehicle. So we worked really hard and developed the techniques today, and the vehicles you see out there today, like the Joint Light Tactical Vehicle with V-hulls that can withstand those blasts. And even as those wars went on, many soldiers would come back and say, I had 3 or 4 blasts and I'm still here. And maybe even the vehicle was still there too. So we really appreciate, looking at these kind of things. And I'm really excited to be involved with Clemson, and we'll tell you more about the virtual prototyping the Army's center that started at Clemson University. But just look at that. Students developed and designed that. And I'm in the vehicle design and development business and assessment business. That's kind of my background. But, autonomous race cars is just an amazing topic for us. Why is the Army interested in that? Well, to be able to go fast is a big deal for us. And so maybe we'll talk more about that. But, I'm just really excited to be involved in projects like this and be up here with this panel. And I'll leave it at that. Thank you.
Thank you, is this on? Put it down. Thank you, David. Excellent. And now it comes the most fun part, I think, is kind of the discussion, if you will, among the folks that we have here on stage. And I'm going to start off with you, Beth. I'm going to start with faster, then we'll go to smarter, then we're cooler, and then safer. So what was the most important thing you focused on going faster and actually qualifying at the 500 when great folks like Will Power could not? So.
Yeah, qualifying this year, for those of you that don't know, the Indy 500 has a 2-day qualifying. Day one, it's the top. There's only 33 cars in the Indy 500. You're not guaranteed to be in it. That's what makes it so magical, and can cause a lot of headaches and hand-wringing if you're on the verge of not being in it, which is what our situation was this year. I will say that selfishly, I was actually happy that there was one of the other Penske cars was having the same challenge, so that people could see that it wasn't because of the lady program, the group of ladies just struggling. But the way that there's so many things that you take into account in racing. It's weather, it's time of day. We had an unusually cool year. And so I get excited when I see things like autonomous vehicles and what that would do. You think of how much testing has to go in, how expensive testing is, and things like that, like understanding what would be different based on a weather day, a precipitation day, humidity, all of those things that happen. Those are things that can be solved with a program like this, and it would cost a lot less than me sending Simona Di Silvestro out on a gray Tuesday, and it would cost a lot less to get that sort of feedback. So what you're really focused on is making sure that your setup is correct, and some of it is a lot of unknown, but everybody's got the same unknown that day.
Absolutely. So getting faster. So Chris, in terms of the AV21 and the teams that are competing for the Indy Autonomous Challenge, what are they doing to go faster? What can they learn from Beth, and what can Beth learn from them?
Yeah, that's a good question. So just to explain it more clearly, the Indy Autonomous Challenge the teams will actually have the identical vehicle. And the only differentiating factor between the teams is the software. It's all about the software. We at Clemson, we built the car. We then had it produced 10 copies of the vehicle, and now it's about the software. And that's a really, really big challenge. So for these teams, in order to be able not only to develop the software, most of the students participating in that competition are computer science students. Now they need to transfer from the software world into the real world. And we have already, during testing, I think, encountered quite a few instances where things work really beautifully in simulation, and then once we put it on the vehicle, there are some problems there. So In terms of where the students, where there's a similarity, I think with the racing world, is that you need to be very meticulous and have a very strict, systematic approach for going from an idea, a piece of software that you may developing, and bringing that incrementally, maturing it along the way until it can be deployed safely and with confidence on a vehicle at high speeds. So I think instilling that in our students, that it's not just, oh, it worked yesterday in software, let's run it on the vehicle. No, we need to have a very strict plan in place in order to make that possible.
Excellent, excellent. So Dave, I mean, in terms of the military and the command, getting a soldier, first responder to get in and help the good guys, or corollary, getting away from the bad guys really fast, is speed a big part of some of the programs you're working on?
Yeah, of course. I mean, the always challenge is, you know, how fast can you go on road, but even off road? So you get into an off-road environment and you're in a hazardous area. Maybe you want a vehicle to go out and do some reconnaissance or go somewhere where it's difficult to go. You know, how do you get that vehicle to go fast? So what I think is really wonderful when we look at like something like the program that Clemson's doing, Deep Orange 12, is, you know, what are they learning? What do the students learn about how to get this vehicle to go fast? I mean, how do you really get something to go 200 miles an hour and do it autonomously? You know, we've learned, at least as we've been developing our own robotic combat vehicles and autonomous systems, that going off-road at high speed is still a challenge. There's a lot of research and lessons to be learned on how to do that. So trying to understand that not only with a program like this, but, you know, taking something off-road, which we were doing as well, and seeing, okay, how long does it take to process this data? How long does it take to get the sensor information back? All these kinds of things become very, very important to us. So, you know, I think as these students learn things like out of Clemson, it's a fantastic place for us to hire those students that actually have already gone through and dealt with some of these problems. Like Chris said, a lot of this stuff you can't even simulate. Once you build a vehicle, then you find out you got all these issues. In the virtual prototyping area, you know, you want to simulate as much as you can up front, but this is really, really new technology that we're looking at.
Absolutely. So we're talking about speed. Obviously, the physical speed is important in racing, but there's another type of speed to product development. And when you think about today, you know, I'll call it traditional manufacturing, tool and die, manufacturing the dies to make the tools, to make the vehicles, some of the vehicles you see out there today. But today that's changed as well. Speed and concept development are at warp speed. The concept of what is known as digital twins. So for every physical prototype you build, there's a digital version of that you can put through thousands of tests for pennies. And you can simulate all those types of things, gaming engines and what is known as generative design. And I can guarantee you Roger Penske's probably interested in that as well, of how to give you the best car next year. So you and Jim Campbell are working together to get that. I remember Roger made a comment to me when he had Detroit Diesel, and he said if he took his winning car from the 500 back to Indianapolis the following year, he wouldn't even qualify. And that's what he really stressed with all of his companies, that you got to stay on that edge. So with that, in terms of faster product development, we'll go back to you, Dave. The generative design and the digital twins and the Viper program that Chris mentioned, which is virtual prototyping, how does that impact what's happening with the Indy Autonomous Challenge? And how's that going to benefit teams like Beth's team so she doesn't just qualify, but she gets on the pole and wins in 2022?
Yeah, so I don't know if everyone knows what digital twin or digital physical twin is, but the idea is you have a vehicle, a physical vehicle, but you have a digital representation of that vehicle, a model of that vehicle, which you can really determine how is that vehicle going to perform without actually physically testing the vehicle. So that's a very popular and very important area, the whole ability to virtually prototype something, but then have a digital twin of that vehicle, because like, for example, autonomous vehicles, you cannot drive it enough and collect enough miles and data to really get that vehicle to a point of where you really rely and trust its performance, and you find all the edge cases, as John said. So having a digital physical twin is really important, but having that digital representation and modeling it, especially to get after these types of problems, are crucial. If you don't do that work up front, then chances are you're going to take the vehicle out there and run tons of problems. It won't qualify. And so you have to do all that work up front. For regular vehicles, you know, there's a very good suite of tools out there to build a digital engineering environment and test out the performance of systems and design changes on those systems. When you get into autonomy, it gets a little more challenging because all the tools aren't there. industry is working to build up those capabilities and tools, but there's still a lot of capabilities. It's just very hard to have an exact digital twin and model everything that something like an autonomous race car would do.
Any comments, Chris?
Yeah. I mean, this actually dovetails very nicely with some of the research that we are doing at Clemson University too. We're working on methods to help advance such digital twin technology. That basically means that we're using model-based approaches to help us predict what the performance of the vehicle will be, and then so that we can then update and advance our designs in order, based on these predictions, basically to improve the performance even further. But the challenge is that the models, of course, are models, and all models are wrong, some are useful, as we all know. That basically means that there's improvement possible in the generation of these models. And this is where the digital twin, I think, is so powerful, that by putting a variety of sensors on the vehicles, capturing that through telemetry, and having huge data sets that then can be used in order to further improve the models through deep learning approaches, for instance, and allowing us to make better and better predictions of the performance of the vehicle, sometimes without ever having built a vehicle, but then once we've built the vehicle, incorporating the data that comes from telemetry to further improve the models so that we can accelerate the overall development cycle even further. And I think in the race world, this could potentially provide significant advantages too, in terms of being able to adapt more quickly to a variety of tracks, environmental conditions, and any type of rule changes that may occur in the automotive context.
Yeah, so, I mean, in terms of that software, and I imagine your driver, particularly at De Silva, I believe, at the 500, does she use gaming and to enhance her skills and simulators, the software?
We did. So interestingly for Simona, the last time that she had been in the Indy 500 was 2016, and one of the biggest changes for this car from when she was there last is there's now an aero screen. And that really changes the center of gravity of the car, and also the buffeting that would happen when you're in an oval situation, you're coming up on a car. Part of the input that the driver has is the wind coming off the car in front, and they can actually feel on their helmet how close they are to the car in front. Well, now that there's an aero screen, that data point is missing for her. So she did some simulator work, but ultimately it was helpful, but it was still not the same as actually getting out and running in traffic.
Absolutely, the popometer, as Wilfred Eibach would say. Yeah, you need to know. And make no doubt about it, folks. Software is the new horsepower, particularly performance software. And I guarantee you, if you're searching for horsepower in a vehicle, remember back in the days with Herb Fishley, I always said the process is worth 20 horsepower. Well, I'm sure Roger Penske would say the same thing now. With some of the digital twin simulation, knowing that going into the race, and knowing that when your competitor doesn't, that's 20 horsepower. And you're not going to get that with push to pass. You're going to get basically the push the knowledge to pass. And I think a lot of that technology transfer is going to go back and forth. So any comments on the software development? Chris?
Well, I can tell you, we can't hire software folks fast enough. In the past, in Ground Vehicle Systems Center for the U.S. Army, we had a lot of mechanical engineers. Now everyone's getting hired into the robotics group and the software group, and we can't bring people fast enough because everything's becoming digital, everything's being software controlled, and it's the key part of our future. So the workforce for us looks quite different than it did 20 years ago.
Yeah, in terms of the software that actually runs on the vehicles, the competition teams, I think, are experiencing that as you increase the speed of the vehicle, it doesn't quite scale linearly with the speed of the hardware on which we run the software. You really need to develop smarter and better algorithms in order to be able to navigate at these speeds. It can't just increase the performance of the hardware. And so I hope that this competition will open up a completely new range of software algorithms that can then be transferred over into passenger vehicles too that we find on the road, and hopefully make them safer ultimately.
Absolutely, making the cars smarter, so faster and smarter. And I would submit, from my opinion, that humans are great at driving, computers not so. Computers are great at making decisions, humans not so. So I think the two coming together, we're going to see drivers, great drivers like Scott Dixon and Colton Hurd, as I mentioned, are working with the Indy Autonomous Challenge folks. I know J.R. Hildebrand is already doing that and getting what's in his head and the popometer attached so that they can actually do things. Ken Block did the same thing with drifting in Gymkhana. So the folks at Stanford got into Ken's head and got that into a drift car that Ken couldn't even beat. So some really cool stuff. So let's switch over to cooler now and start with you, Beth. Racing is obviously going through a lot of changes. Look what's happening with NASCAR and predicted demise for decades, but it's still surviving. But you look at IndyCar, it's growing like crazy, particularly now that Indy is owned by Roger and the Speedway. What's it going to take for new fans and traditional enthusiasts to stick with racing? What do you see in terms of creating that next generation of people that just want to go to a racetrack and see racing?
I think one of the biggest growths, where you're seeing growth is in gaming. So you have people younger. There's a lot of virtual racing happening, and people are being introduced to it that way. The thing why I think racing, we still need to invest in it, and we hope that it continues. Is it's the one thing about in all of this, Motorbella. We're all here to talk about transportation and all of the tentacles that leads to. But racing is emotional. It puts emotion back into cars. It's something that you can get behind and root for, and it's man versus man and man versus self and building a better mousetrap and all of those things and not knowing how the day is going to turn out. All of that is emotion and kind of keeps the fun in it and keeps the engine driving. So that, I think, is where the cool thing is. How do we get young people involved? Keeping that going and keeping that excitement. A lot of what we had noticed is that the reason why my push for diversity and why you're seeing other pushes for diversity is the audience needs to, the participants need to mirror the audience. The audience needs to see themselves. They need to look up and down the grid and see, because not everybody wants to be a racing driver. And if you say that to a racing driver, they're shocked by that not everybody wants to be them, but that's the truth. But there's so many roles within kind of putting this show on, and I think that the more we lift the veil to kind of point out what all those roles are, you realize there's a place for you in this. Absolutely. And I think the two things are showing the emotion, showing that it's for everybody, and also for racing to embrace gamers and then bring them to kind of cross the bridge and say you can do this at home and you can also see it live.
So not just inspirational, but aspirational as well.
Exactly.
That's great, and great role models like yourself that are paving that way.
Thank you.
Good, pleasure. So Chris, is racing still cool with your students and a lot of the motorheads and chip heads down at Clemson?
Yes, typically in the fall semester, before the Deep Orange project start, we have an application process because there's always more students who want to be involved in the project than we can accommodate. And it's not unusual that we have maybe 30 or 40 students applying to join the team. Well, when the Deep Orange 12 project was pitched up as a potential project for them to work on, we had almost 90 students coming forward and say, oh, I really want to be part of this team. So it definitely still inspires, and I can tell that even during the COVID times, because the entire vehicle was being developed while COVID was happening all around us, even during those times, the motivation in the students was phenomenal, and they wore their mask and even the respirators while they were coming to the lab to work on the vehicle. Definitely an inspiration, yes.
Excellent. So obviously some of the technologies you're working on, David, got to be cool. I mean, why would GM Defense have the JLTV Colorado derivative here if it wasn't cool about that? So you've got a lot of young gamers working for you.
Oh yeah, well I just got to tell a personal story. I have a young 5 and 7-year-old son, 5-year-old daughter, and I took them a few years ago to the racetrack, and then just recently we took them to the qualifier for that vehicle, and we got pictures of them there. But when they see those cars and they can touch them, feel them, see them go around the track, hear them roar, they're pretty excited. So my son, has so many Matchbox cars, I don't know where they all are. But they'll be driving in my back seat, and a Corvette will come flying by my car, and they're like, race car. My daughter will too. Say, wow, look at that one. What kind is that, Daddy? And of course, it doesn't hurt my son. We took him out to an Army base, got him to crawl on some of the robotic combat vehicles and the Bradley vehicles, and he's like, how big is the gun? He's asking the engineer. To see that excitement in them, I'm kind of excited because maybe they'll be engineers one day. I think it's really, really important, even in our workforce in the Army, We have a lot of engineers and scientists, you know, over 1,500 engineers and scientists at our place. Some of them are buying parts for vehicles and never have driven the vehicle or sat in the vehicle. And I think that's a really crucial experience for people, is to actually get out there, see these vehicles. And my son, you know, he wants to design them in Roblox and these other virtual environments too. And so before I know it, he's over there designing vehicles and saying, how big should the tire be in some game I didn't even introduce him to. So I think the desire is there. If they get early and see these technologies and vehicles, can play with them, it's exciting to them, and it sticks with them. I mean, years later, they're still excited to go, and I hope to bring them on October 23 too.
Absolutely. Yeah, we didn't get a chance to talk much about EV, electrification of racing, but that's coming as well. Stay tuned. We got some really cool stuff happening with King of the Hammers. The first electric vehicle is going to race in January out in Johnson Valley, California. And Tim, we should have a demo here with Rod and the folks here at Detroit Grand Prix and Detroit Auto Show 2022. So this is the last question. This is for all the points. Who gets invited back next year? I don't even know if I will. But, so this is the last question. What's the most important thing that, if in our audience today we had Steve Jobs sitting there, or Soichiro Honda was there, or Louis Chevrolet, or Billy Durant, what's the most important thing any one of those people should take away from our conversation today on going to the Gemba, the future of racing, and advanced technology? So we'll start with you, Beth.
That's a hard one. And I'm going to go against the grain a little bit, because we can keep talking about the technology and everything, but I still think fundamentally the most important thing that we can't lose sight of is that emotion matters and feeling about these things matter. Half the cars out there you don't need, but you buy them because you want them. The want matters. We could all, and I could make a disparaging comment about a vanilla sedan, because we all can think of one in our head. And if emotion didn't matter, we would all drive that. But nobody needs a Ferrari. Nobody needs an Aston Martin. Nobody needs a Lamborghini. They're sold based on emotion. Nobody needs a tricked out Range Rover. But all the technology is interesting, but we still have to remember that the humanity of it is what is the last 5 yards and what makes it sell. And maybe the safety, maybe this, maybe that. Why do we care about safety? Why do we care about safety of our family? Because it's emotion, because we love our family, because we want to have a good day out. Don't, with all the science and all the technology, don't lose sight of that the most important thing is how it connects to us being human.
Very good. So how you feel is just as important. And people buying emotion and justify with logic. Very good. So what's the most important thing, Chris, that this audience should know?
Let's see. I hope you will take away from this that yes, racing is really, really cool, and we all love watching it and being part of the whole ecosystem around it. But it's important that we recognize that it goes well beyond just the racing world, and that it has a significant impact on the students in our program, on students all over the world who get drawn in. And it's not just the gearheads as it used to be, but I hope that through a competition like this, we pull in the computer scientists of the future too, and get them excited and get them invested into this world too.
Very good. So Dave, you get the last word.
Yeah, good. I'm glad I got to go last. I had to think about that one for a minute. You know, I think it's a really exciting time for ground vehicles and the automotive industry. I mean, we're in the center of so much that's happening and so many important things. And, you know, I tell people, you know, just don't think of a vehicle as a vehicle on wheels that drives somebody around. I mean, it's a supercomputer on wheels. It's a node on a network, right? It's so many more things than just what we thought of as vehicles before. And, you know, it's so important in terms of not only the environmental issues now today and going electric vehicles or hybrid vehicles and that whole aspect to society, but also with autonomy, you know, and I'm just thinking, I hope these autonomous systems are out on the road in 5-6 years so they can drive my kids to soccer practice, right, and ballet and everything else. I mean, they're gonna have such an impact on society, and we're right in the center of it here. And so, you know, looking at all these technologies and what the societal impacts are, and also the skill sets, the type of people that are going to be developing these systems in the future are very different than what are in our labs and in industry today. So like we were talking about just having more software people, it's very different. So it's really an exciting time in this whole space, and I guess that's my big takeaway.
Excellent. So thank you very much. That concludes our program, and please join me in thanking Beth, and Chris and David for sharing their insights with us today. Thank you.